Okay, now members, in this lesson we are going to see the condition for tangents of a line to parabola, and also we are going to see the specific point of contact between that tangent and then the parabola. Now, look at the condition for tangents. It means that a tangent meets a parabola at one point. Now, if we have this as our equation, it's that B having 1 point, always the discriminant should be equaling to 0. So the whole of this should be 0. So we shall be having here 1 point step. Always here, x will be negative b over 2a if this is 0. So that we have 1 point, only one value of x. Now from here, what we do, because at this point of contact, always the y of this line is equal to the y of that curve. So we put this one here, we form a quadratic, then we put this condition for tangent. So when I put this in here, I have equaling 0. I take this side, then expand, plus. So from here you see, I have this coefficient of x and this, so what we add in, then plus, equaling to 0. So start from here, this is my A, this is my B, and this is my C. If I compare the general quadratic equation like that, equaling 0. So this is my, so from here there, it's that my A is m squared, my B is, remember, this is C please, this is not x, C. So my B is 2mc minus, and my C is C squared. Now I know the condition for tangents, or is for tangents, my B squared minus is equal to 2 or a C. So now if I put my B in here, I have C squared. So now we expand this. We have 4 m squared, C squared. This time this will be 16 mcm, then plus C squared. So start now, this and this is cancelling. Now when I take this the other side, I have 16m. I take this the other side, Ca equaling to this a squared. So see if I divide it through, goes, then 1 goes. So from here, I have mc equaling to a. And if I make C the subnet, you start my C will be a over n. And this is what they want me to show. Show that this and this is the condition for tangents. Now, if I have this, now you know that I want to get a point of intersection. I know that because this is true, then we have only one value of x. So x is negative 2b. I mean it's negative b over 2a, which will be negative. Now our quadratic was this. Our base here, 2mc minus 4a, the whole over 2a, but our a is m squared. So my x will be now negative into 2m. Now I know what c is. Then minus 4a. But I know what a is. My a from there, okay, I did there my a for a, the whole over, this will be 2m squared. Now start our a from this side, our a was m squared. Anyway, so start this m is going to cancel this m. So when I have, from here I have 2a minus that, I'll be having my x equal to negative. Now this will be 2a minus 4a, it will be now minus, I need to be now positive 2n all over 2n squared. Now, you see that this and this cancels, then my x becomes a over n squared. Now I want to get the value of y. The value of y, I know that from y equal to mx plus c from this line. So my y will be now n. Now I know the value of x. This x is here. Then plus which is a over n from here. Simplify, start this m, it's going to cancel, you'll be having y equal to a over m. So now members, from there you see that the point of intersection or is between a tangent and a parabola is a over m squared, comma, 2a over m. That is or is the point. So please don't confuse this a is a of this, don't confuse it with m. Now from there, I can prove that the line this is a tangent to parabola this, and hence find the point of intersection. All you do, you put this here. So I put this here, and we are now. Let us expand. When I expand, I have n plus 16x. You can divide it through by 4. You have x squared plus 2x plus 1 minus, now when I bring it inside, I have 4x equal to 0, divided through by 4. So this will give me now x squared minus 2x plus 1 equal to 0. And you see, this is the repeated. For that, I mean, what goes with the factors? What is squared to squared net x squared is x minus what is squared to net 1 is 1 squared equal to 0, so that the x is 1. Now, if you want to say that it's a tangent, now first of all, you first come back here. You know that first of all, this is the point. So from here, so that our x squared minus 2x plus 1 is equal to 0. So our a was 1. Our b was negative 2 and our c was 1. If it's a tangent there from b, it should be equal to SC. So, then 1c4 is equal to 4. Meaning that now this is the tangent of this. Now, get the point of contact, you solve it the way you solve it there. So if this is y, remember you add y equal to 2x plus 2. So y will be 3 into 1, then plus 2, and you see this will be a 4. Then the point of contact will be, now the x which is 1, then 4. I say 4 as that. Now, look at this question here. What if we knew that to prove, we always show that always our C alternative here. Our C, for any line to get condition with a parabola, our C is always equal to 2, I mean A over A. Now, from here, we know that if I compare this, I have y squared equal to 6x, and my y equal to x plus 2. But this one, I compare it with the general. Then this one, I compare it with the general, going to number 9, mx plus c. From here is that, if I compare that my A is going to be 4. That from here my M is 2 and my C is 2. The condition for them to be is that always, I should say, always C is equal to A over M, which we proved here by the way. So mean that my C is now 2. So my 2 should be equal to A, which is 4. Over n, which is 2, and that 2 is equal to 2. And then the point of contact, we say the point of contact is a over m squared, comma 2a over m, which will be now this point, my a is 4 over m squared, where square m, I get 4, comma 2a, so I have 2 times a, which is 4. The whole over n, which is 2. So that this will be so which is 1, comma. This will be 8 divided by 2, which is the 4. And it's the same point we have here. So members, if you know this idea, you don't need to go through all this. I wish you the best. Don't forget to subscribe to the channel.